Polynomial, you see it has a double root at x equals 1. Use synthetic division to find the other root. So with synthetic division, we take the polynomial. So we have 2x to the fourth minus 5x to the third minus 6x squared plus 19x minus 10. And we strip away everything except for the coefficients. So we just have to make sure that we've accounted for every exponent from the high power down to 0. So as long as every exponent is there, you're good. So we got a 4, 3, 2, 1, 0. We didn't miss any along the way. So the coefficients are 2, -5, -6, 19, and -10. All right. If it's a power of 4 polynomial, you should have 5 coefficients. If it's a power of 6 polynomial, you should have 7 coefficients. Always one more with the coefficients. All right. And they tell us that we have a double root at x equals 1. So when I'm setting up my synthetic division, I'm going to put a 1 on the outside. This is always going to be a root. All right. If they don't give you a root, you can just look at the calculator and see where it crosses the x-axis. So I'm going to pull down the 2, then multiply by the 1. That'll give you a result. Then add. So we get a -4. Then take this result, multiply by the 1. Add, we get a -10. Take this result, multiply by the 1. Add, and we get a 9. And then take this result and multiply it by 1. Although now I'm thinking I probably made a mistake somewhere along the way, because it should work out. So 2, -5, -6, 19, and -10. Pull down the 2. Oh, yeah. It sucks when it happens very early on in the solution. All right, yeah, so 2 times 1, fun fact of the day, is 2. All right, -5 plus 2 is -3, times the 1 is going to give you a -3, -9, multiplied by 1 is -9, which gives you a 10, multiplied by 1 is 10. All right, because it's a double root, that means that you can do that process a second time. So I'm going to build off of this, again with that second 1 on the outside. Pull down the 2. 2 times 1 is 2. -1. -1 times 1 is -1. Sum of -10 times 1 is -10. And that gives you a 0, so that goes away. All right. So we started off with a power of 4. When you divide by a linear factor, your result is going to be a power of 3. If you divide by a linear factor a second time, the result is going to be power of 2. So we're going to pop in an x squared to start, and then decline our exponents by 1 every step of the way. So the next one would be x to the first, and then x to the 0. So then what we want to do is take that 2x squared minus x minus 10, and either factor it or use some other technique to simplify. So we'll try factoring 2x and x. All right, I'm thinking if I'm going to get to a 10, it's probably going to be 5 and 2 in some order. So we got a 4 and a 5, so this is negative and that's positive. That'll get the job done. And so now we set each of those factors equal to 0. And solve, you get x equals 5 over 2, x equals -2. All right, but that last part's just factoring. Yeah.